Welcome to Mr. Connor's Crazy Kitchen, the clever show with all the great ideas. Today I'm going to show you how to make the humble cheese sandwich, which we have a lot to learn from. I've got a special recipe. The other science staff often laugh at my recipe, maybe because I don't use margarine, but this cheese sandwich is so good that if you have it with a cup of tea or you toast it, you can actually manage to swallow it. I've been having these for years. And actually, maybe the reason they laugh at me is because I don't actually make the sandwich. I just take the bread and cheese and whack it together at lunchtime. But anyway, let's learn how to make the humble cheese sandwich because it has a lot to teach us. First thing, I've got my cheese, I've got my scales, I've got my bread. And we need to take 200 grams of cheese and 200 grams of bread. And what's that I hear you say? You don't make sandwiches by measuring grams of bread and grams of cheese because the mass is not important. It's the number of slices. So we're going to forget about mass. I could throw the scales over my shoulder. I think my wife would get very cross. So let's just put them there. We are not interested in mass, just number of slices, bread and cheese. Okay, so let's take 10 slices of bread and 10 slices of cheese. And what do I hear you say? That's not going to work, is it? Because what's in a sandwich? How many slices of bread? 2. How many pieces of cheese? 1. With the plastic on, because the cheese is so plastic it doesn't make any difference. 2 pieces of bread, 1 piece of cheese. So what do I need? I need twice as many bits of bread as cheese. 5 bits of bread. 10 bits of bread, 5 bits of cheese. And what has the cheese sandwich taught us already? Mass doesn't matter, just the number of slices, and you've got to have them in the right ratio. And that is going to help us a lot with our chemical reactions. Now, I want you to stop in a second, and I want you to do the PhET simulation that lets you make sandwiches. This is a scientific simulation that gets you making sandwiches. And you can do the first part of the activity sheet, fill in the table by making the sandwiches. Okay, pause the video now. Okay, welcome back. I hope you found the activity fun and easy. And what have we learned? To make a sandwich, you need 2 bits of bread, 1 piece of cheese, and what do you get? 1 sandwich. And I hope you're starting to see that that is a lot like a chemical reaction. For example, if you had hydrogen and oxygen reacting to form water, you would take a certain number of moles of hydrogen, a certain number of moles of oxygen, and you would get a certain number of moles of water, and you always get the same ratio. So what you're going to do now, what do we learn from the humble sandwich? I want you to look at the next bit of the PhET simulation, the molecules, and you're going to do exactly the same thing as what you did with the sandwich, but this time you'll be using hydrogen, oxygen, and water, and you'll see exactly the same principles apply. So stop now, and you're going to look at part 2 of the task. Don't worry that you haven't finished all of part 1. Go to part 2 and do the first part using the simulation. Okay, welcome back. We're not finished learning from the sandwich yet because the humble cheese sandwich can teach us something else. What if we did have masses? Because in a chemical reaction, often you are told the mass of something, you're not told how many moles. What if I was told I have a certain mass of bread? 500 grams of bread. How many sandwiches can I make? What would I do? So the next part of the activity, you're going to go back to part 1. We've seen that you need to think about slices, not mass. We've seen that you need the right ratios. But what if you are told a mass of bread? What do we do then? So the next part of the task, you're going to start with a mass of bread, and you're going to work out, how do I work out how many sandwiches I can make from a mass of bread? And how do I work out the mass of sandwiches? So have a look at part 2, introducing mass in the bread cheese sandwich calculations. Have a go at that. Pause the video and come back when you're finished. Okay, welcome back. Now, how did you take a mass of bread and work out the number of cheese sandwiches or the mass of cheese sandwiches you could get? Hopefully what you did, the first step is you needed to work out the number of slices of bread because it's slices that's important. So when you're given mass, first step is convert it to slices, mass to slices. Once you know this number of slices of bread, then you can use the ratio in your recipe to work out the number of sandwiches. And in this case, because it takes 2 pieces of bread for 1 sandwich, you had to halve it to get the number of sandwiches. Once we've got the number of sandwiches, how would we find out the mass of sandwiches? We would multiply it by the mass of 1 sandwich to get the mass of the sandwiches. And that process is a lot like what we do in chemical reactions. If we are studying a reaction, the first thing we have to do with masses is convert them into number of moles, not number of slices, but number of moles. Then we can study our reaction and we can go back to mass at the end. So, when we go to chemical reactions, if you're given the mass of a reactant or a product or something, and you are going to study the reaction, what is the first thing we're going to have to do? Convert it to moles of reactant or product or whatever they've given you. You convert it to moles. Once you know the number of moles, then you can look at the ratios in the equation and you can work out the moles of anything else in the reaction, like the moles of product. But when you're looking at the reaction, it's not mass, just like the cheese sandwich. It's moles, always moles. Once you know the moles of product, you could then convert it back to a mass of product. That's key. And you've already learned how to do this conversion using number of moles is mass over molar mass. Now, that's the process. You've done this part. So what I want you to do now is go back to part 2 of the task when we're looking at molecules and chemicals, and do the next part where you're introducing mass in chemical reaction. And it asks you to try to work out this and apply this to hydrogen and oxygen and water. So pause the video now and have a go at that one. Okay, welcome back. You may be thinking there's nothing else left to learn from this humble cheese sandwich, but there's still one more thing that it can teach us. What if we are given the mass of bread, so we know we've got a certain mass of bread, and we've got a certain mass of cheese, and I want to know how many sandwiches I can make, or what mass of sandwiches I can make. That's a bit trickier. What would we do then? If I've got the mass of bread, what's the first thing I need to do before I can work it out? I need to convert it to the number of slices. The mass of cheese, what do I have to do? I need to convert it to slices because our recipe involves slices. I've now got the number of slices of bread and the number of slices of cheese. What's the extra step I'll need to do? I need to work out which one will run out first. So if I have 10 slices of bread and 8 slices of cheese, for example, I need to work out that actually 10 slices of bread, that's not enough for 8 slices of cheese. I'm going to run out of bread first. And we call that the limiting reagent. So if we convert them both to slices, we can use our ratio here, 2 to 1, to work out which one is going to run out first. Then we'll know how many sandwiches we can make. And that is exactly the same in the chemical reaction. If you're given, for example, the mass of hydrogen and the mass of oxygen, how much water will we get? Well, what's the first thing you need to do? Convert the mass to moles of hydrogen. Convert the oxygen to moles of oxygen. And if we know how many moles of hydrogen we've got, how many moles of oxygen we've got, we can work out which one is going to run out first. We need twice as many moles of hydrogen as oxygen. If we don't have twice as many, we'll run out of hydrogen. If we have more than twice as many moles of hydrogen, we'll run out of oxygen first. And when we've worked out which one will run out first, that's the limiting reagent. That's the one that controls how much of the product we'll get. So in a moment, you can do the final part of part 1, looking at the bread and cheese, and it includes limiting reagent. Then you can go on and do the final part of part 2 on the chemical reactions, where you have the limiting reagent. What's the aim of all this? What are we trying to do? There are 4 big learning intentions that we've mostly covered, and we're now going to practice. The first one is, you need to be able to use mole ratios in an equation. Like if I had, let's actually go to reactions. If I had a certain number of moles of this reactant, how many moles of this do I need? How many moles of this would I get? That's the first outcome, to be able to manipulate moles in the ratios. The second thing, if you're given a certain mass of something and you're asked how much product you would get, you need to be able to work that out. And what's the process? I would go from the mass to the number of moles of that reactant, then I can work out how many moles of product and the mass. The third learning intention, if you're given the mass of one reactant, you need to be able to work out the mass of the other reactant that would be needed. So if you're told a mass of hydrogen, what mass of oxygen would need to react with it? And what's the key? Convert to moles first. You would have to convert this to moles, then you'd know how many moles of that you need, and you can work out the mass you'd need. So that's the third learning intention. You need to be able to do that. And the fourth one, you need to be able to work out, if you're given the mass of two reactants, which one is the limiting reagent. So they're the four learning intentions, and there's some activities you can do from Conquering Chemistry and Chemistry in Focus that will help you practice each of those four learning intentions. And these are crucial for all of chemistry. It's a really important skill to learn. I hope you've enjoyed the cooking show. What are we in, a chemistry or a cooking show? Whatever we're in, I hope you've enjoyed it, and make sure you contact me, send me an email or something if you're having any trouble with the work. I'll catch you later. Bye.